Okay, now let's start. Just now, we have calculated the difference and transform the differences into ranks. And then we attach the signs of the original differences to the ranks. And now we need to calculate the test statistic for the null hypothesis. So, what is the test statistic? We need to sum the rank up. And we said that we have positive rank and negative rank. And we need to sum of all positive ranks and all negative ranks separately. So for the positive rank, we can get T plus. So that is the rank sum for the positive ranks. Here we can find that we sum all the positive rank up. And then the result is 131. So that is T plus. For the negative ranks, we can get T minus. For T minus, we can sum all the negative numbers up. And finally, we can get 59. So that is T minus. And we said that in Wilcoxon signed rank test for one sample test, we need a single test statistic, T. And in this method, we can choose either one from T plus and T minus. For example, here in this question, we choose T plus. So the test statistic T value equals to 131. Of course, you can choose the T minus. So the T should be 49. But please notice that you can only choose one from the two as a test statistic. And finally, you can get the same conclusion. So either one is okay. Okay, so here, in step 2, we do the calculation. The first, the sample size n is 19 because actually we have 20 patients in this example. We have 20 men in this example. But when we calculate the differences, we get a 0. So we omit the 0. So the sample size should be n minus 1. That is 19. And we finished the calculation of T plus and T minus. And here we choose T plus as the non-parametric test statistic. So T equals to T plus equals to 131. Next step, in step 3, we need to make the decision. So the similar ways what happened in the other hypothesis tests, we need to check a critical value or a standard value from a special table. So here in the Wilcoxon signed rank test, we need to use table A3. So let's go to the textbook. And turn to the appendix table, table A3. Table A3. So this is the table A3. So this is the critical values for Wilcoxon signed rank test. Please notice that we will use 3 tables in this chapter, and each table is different from the others. And we need to read the title of the table. You will find that here. The title for table A3 is Critical Value for Wilcoxon Signed Rank Test. So this table is only used for Wilcoxon Signed Rank Test. So that means this table is only used for one sample test or paired samples test. Okay, so here, the first column of the table is the n, but please notice that this n is not the sample size, which is given in the question. This is the sample size of the differences omitted, 0. So that means this is the number of now 0 differences. For example, in this question, the little n equals to 19. We have 20 young men in the question, but we found that difference equals to 0, so we omit it. So n equals to n minus 1, that is 19. So n equals to 19. So we need to find the number of 19. And next one, here in the first row is two-sided comparisons, and below that is the alpha. So we said that in our hypothesis test, alpha equals to 0.05. So here in the cross position, we can find this number. But please notice that here is an error in our textbook. This is not a number of 46.144. It's actually a range. All the numbers listed in this table should be a range. So this range should be 64 to 144. That should be this range, not just a number. So what's the meaning of this range? So how can we identify what is the p-value based on the range? Let's go back our PPT. Here we have found that this is the range. This is the critical range we get from table A3. So here we need to compare the test statistic with the range. If the test statistic locates inside the range, that means the p-value is bigger than alpha. Please remember that. If the test statistic locates inside the range, that means p is bigger than alpha. But if the t-value is outside that range, that means p is less than alpha. Outside means two conditions. The first one is t is less than 46, or t is more than 140. So both of these two conditions, that means p is less than alpha. But if t is bigger than 46 but less than 144, that means p is bigger than alpha. So By using this way, we can know the results of the step 3 of the hypothesis test. In this question, we can find that t equals to 131. The number locates inside the range, so that means p is bigger than alpha. I have mentioned that we can get two t-values. The first one is t plus and the second one is t minus. You can choose either one from the two because they have the same conclusion. Now let's prove it. If we choose another number as the test statistic, t equals to 59, you can find that these two numbers have the same conclusion because both of these two numbers locate inside the range, right? So the results are the same. P is bigger than alpha. So you can choose either one of the two t-values because they can have the same result. Okay, so here, according to our result, we can know that in this question, since t equals to 131, which is included in the critical values range, we cannot reject H0 because P is bigger than alpha. So the conclusion should be the current median height of the age group is not significantly significantly different from 69.7 inches at the 0.05 significance level. So that is the answer to the question. I think the most important thing is how to get the test statistic, how to calculate the difference and transform the difference into its corresponding rank. So I think there are some important points you need to remember. The first one, if there is a difference equals to 0, we need to omit it. And the corresponding n should be -1. And the next one, when we order the numbers, we need to arrange the differences in order of magnitude, ignoring signs. But after that, we need to attach the signs of the original differences to the ranks. When we calculate the test statistic, we need to sum all positive ranks up and sum all negative ranks up. And from the two t-values, that is t plus and t minus, we can choose either one from the two as the test statistic value. In table A3, we need to compare the test statistic with the critical range. If the test statistic is locates inside the range, that means P is bigger than alpha. But if test statistic is outside the range, that means P is less than 0.05, less than alpha. If the test statistic is inside the range, that means P is bigger than alpha. Okay, so this is the Wilcoxon signed rank test for one sample test. And next one, here is another example. We use the same method, Wilcoxon signed rank test, but this is an example of paired samples. So we can know that the Wilcoxon signed rank test can be used for paired samples test 2. Okay, so you can read the examples by yourself. Okay, I think you have finished that. In this question, we can find that some keywords, what we have mentioned in paired samples t-test. The keywords is before and after. And we said that in chapter 6, when we find the keywords of before and after, we can know that it's a paired sample. So here is the same. This is the paired sample, and we can find that we assume that this question is shown in chapter 7. So we assume that the data does not follow a normal distribution. So the question is test whether the drug is effective in reducing blood pressure of hypertensive patients. So that means we need to compare the difference of before and after. So this is a paired sample test. By using the non-parametric test, we can still use Wilcoxon signed rank test. So it follows the same procedure with the former example. The first step is to establish two statements of hypothesis. H0 is the same, median equals to 0. But here we can find that it's not median of x equals to a given median, because that in these questions there is no given medians. Let's review what we have learned in chapter 6 when we are solving a question about a paired sample t-test. In chapter 6, in the hypothesis test of paired samples t-test, we need to calculate the difference of before and after. And we try to test if the difference is symmetric around 0. So the H0 is mu D equals to 0. HA is mu D is not equal to 0. Right? So it's the same in chapter 7. We also calculate the difference of before and after. In this example, we use X to represent before, Y represent after. So D means the difference of before and after, the difference of X minus Y. And here, if the drug is useful, that means different can be found between before and after. So that means the difference or the differences cannot be symmetric about 0. But we have already known that the data does not follow a normal distribution. So we cannot use mean anymore. We can only use median to represent the certain position, the certain location of the distribution. So here we try to test if the median of the difference equals to 0. So we can get the H0. H0 should be median of the difference equals to 0. And HA is median of the difference is not equal to 0. Alpha is still 0.05. So we list all the numbers in this table. Okay, the procedure is similar with the former example. Here, we calculate the difference of before and after. And N is the number of non-zero differences. It's the same with the last question. And then arrange the n differences in order of magnitude, ignoring signs. A sign ranks to the absolute differences from smallest to largest. A sign ties the average of the ranks which will be assigned if the difference have not been tied. Disregard all zero differences, and then attach the signs of the original differences to the ranks. So here, we list all the difference here. And then let's find the smallest absolute value of the difference. Which one is the smallest? This one, right? Its absolute value is 2, is the smallest, so its rank is 1, and we attach the signs of the original difference, the original difference to the rank, so its rank is -1. And which one is number 2? This one is -5, so its rank should be -2. And the third one is 30, but we can find there are 2 numbers of 30, so they are ties. They have the same rank, and in theoretical, these 2 numbers should be ranked number 3 and 4. So here we use the average of the 2 ranks. So the ranks of the 2 numbers is 3.5. And next one is 33. So its rank is 5. And the next one, we have 35. 2 numbers of 35. So their ranks should be the average of 6 and 7. So that is 65. Okay, so now we list all the ranks for all differences. And here, there is no difference equals to 0. So the sample size, the n, equals to 10. Right? Because we have 10 patients. So the sample size equals to 10. And next one, we need to calculate the t plus and the t minus by sum all positive ranks or sum of all negative ranks. So here we can find that we have only 2 negative ranks. So the negative t is 3. We can find here this number is without signs, right? And next one, t plus, we can sum all the positive ranks up and we can get 52. So here we can choose either one from the 2. And in step 3, we need to check the standard range or the critical range from table A3 by using the little n. Okay, so now let's go to the textbook. Little n is 10. So here, 10. And we can find that when alpha equals to 0.05, the range is 8 to 47. I have mentioned that this is a printing error in our textbook. This is not a number of 8.47. It should be a range of 8 to 47, a range of that. So here is the range, and we can find that no matter which number we choose, the two numbers locate outside the critical range. So that means the p is less than alpha. So we need to reject H0 because p is less than alpha. So the conclusion is before and after they are not the same, right? So the whole conclusion should be the drug significantly changes the systolic blood pressure of hypertensive patients at the 0.05 level of significance. So that is the answer to this question of paired sample rank sum test. Okay, so here, this is the first type of rank sum test. We call it Wilcoxon signed rank test. And this method can be used for one sample test and paired sample test, but the precondition should be the data does not follow a normal distribution. Okay, next one. The second type of rank sum test is two sample test of central tendency. That is the name in our textbook, but most oftenly I'd like to call it Wilcoxon rank sum test for two independent samples. Please notice that the name of the method, Wilcoxon rank sum test, this is different from the first method. The first method is Wilcoxon signed rank test. The key point is signed, because the signs is what we must consider in the question. But here, in the second method of Wilcoxon rank sum test, there is no signs anymore. Or we can say that we don't need to worry about the signs. Okay, so here, the WRS means Wilcoxon rank sum test. The WRS test is assumed that X and Y are independent samples from distribution of the random variables X and Y, respectively. We wish to test H0, median of X minus median of Y equals to 0. So if the difference of the medians of X and Y is rarely equal to 0, that means there is no difference between X and Y. So that is same to say H0 should be median of X equals to median of Y. So here, X and Y are the two variables and they have no relationship between X and Y. So we call it independent samples. So it's the same with what happened in chapter 6 in two independent samples t-test. We have mentioned that if you can find some keywords such as before and after, matched or paired, that should be paired samples. But if you cannot find this kind of keywords, that must be independent samples. So it's the same here. Okay, so the most important thing here is the procedure for us to calculate the test statistic. And how can we get the test statistic? we have a similar procedure. Number one, rank all the observed values in the two groups from smallest to largest. Please notice that we need to rank all the pooled values in the two groups. Pooled means we need to put all the numbers in the two groups together and then rank them. And then assign the average of the ranks if the observation values are equal. That is to say, when we match a tie, we need to use the average of the ranks. Number two, sum the ranks separately in each group. Please notice that when we rank the numbers, we pool all the numbers together. But when we calculate the rank sum, we need to sum the ranks separately. Number three, the test statistic T is the sum of the ranks for the smaller sample. So that means we cannot choose either one from the two anymore. We need to choose only one. We need to choose the only test statistic for the smaller sample. So that means which group has the smaller sample size, we need to use its corresponding rank sum as the test statistic T value. The test can be done based on critical values shown in table A4. We need to reject H0 if T is outside the critical range. So that means we need a new table here in this method. That is table A4, not table A3 anymore. And in table A4, it's still a critical range. So it's similar with table A3. If we find that the T value is inside the critical range, that means P is more than alpha. We cannot reject H0. But if we find that the T is outside the critical range, that means P is less than alpha. So we need to reject H0. Okay, so now let's watch an example. You can read it. Okay. This question is very short. Here, the question is to test whether the proportion of calories in grades 5 and 6 and grades 7 and 8 is different at alpha equals to 0.05. So that means we divided all the boys into two groups. The first one is grade 5 and 6, and group 2 is grade 7 and 8. So here is the data. We can find that this is group 1, the proportion from fat. This is group 2, and here group 1 and group 2, they are independent. So how do you know they are independent? Do you remember that? In chapter 6, we have mentioned that if the two samples, they are matched, they must have the same sample size, right? So that means N1 must be equal to N2. So if they are equal, it can be paired samples. But sometimes they may be maybe they are not paired samples. But if we find that the sample size of the two samples of the two groups, they are not equal, that means the two groups must not be paired samples. So here in this question we can find that the sample sizes of the two groups are different, so that means they cannot be samples, they cannot be paired samples, they must be independent. Okay, so this is a question about independent samples, and we assume the data does not follow the normal distribution. So here the most important thing is how to get the test statistic. And we have mentioned that we have the procedure for calculation of the test statistic. Okay, so first we need to pool all the numbers and rank them. So that means we need to put all the numbers together and then order them. So here we put all of the numbers from group 1 and group 2 together, and among all the numbers we need to rank them from the smallest to the biggest. So let's find it. Which one is the smallest? Here, this is the smallest number, so its rank is 1. And the second one is it's here, 0.150, so its rank is 2. And the next one should be 0.225, so its rank is 3. Okay, so we need to rank all the numbers, and we need to transform all the numbers into its rank. But if we find two numbers that are the same, for example here, this number and this number, we can find that there are two numbers that are the same, 0.337. So that means they have the same rank, and their rank should be 16 and 17. We need to use the average of the two ranks. So they should be 16 plus 17 over 2. So both of the two numbers have the same rank, that is 16.5. Okay. And then we need to sum the ranks separately in each group. So that means when we rank the numbers, we need to pull all the numbers together. But when we sum the ranks, we need to do that separately. So here we calculate the summation of the ranks in group 1, and then we calculate the summation of ranks in group 2. We can get two numbers. For group 1, its summation is 224.5. So that is the rank sum for group 1. And here 336.5. That is the rank sum for group 2. So here we can get two rank sums. We can use T1 and T2 to represent its corresponding rank sums. And here we need to choose only one from the two as the test statistic. So which one should we choose? I have mentioned a rule before. That is, we need to use the sum of the ranks from the smaller sample. So which one has the smaller sample size? Of course, group 1, right? So we need to use T1 as the test statistic. So that means test statistic equals to 224.5. Okay, so here, let's watch the whole procedure of the hypothesis test. Step 1, H0 median of x equals to median of y. So x and y actually mean group 1 and group 2 in this question. And next one is this is HA, not H1. HA, the alternative hypothesis, should be not equal. Median of x is not equal to median of y, and the significance level alpha equals to 0.05. Step 2 is to calculate the test statistic, and the procedure for the calculation is shown in the last slide. So here we can know that the test statistic equals to 224.5. Okay, next one, we need to use table A4 to find the critical range. Okay, let's go to our textbook to find table A4. Table A4 is similar with table A3. So it's here. Okay, so let's read the title for table A4 first. Critical values for Wilcoxon rank sum test. This is very important. Let's compare this title with the title for table A3. This is the critical values for Wilcoxon signed rank test. They are different, right? In table A3, it's used for signed because we calculate the test statistic by using the signs. But the signs is not useful in two independent sample test. So the title is Wilcoxon rank sum test. That is the name of the method. Okay, so here in our question, the sample size of the group 1 should be 14, and the sample size for group 2 is 19. So we need to use the smaller one. So sample size is 14. So let's find 14. Okay, so here we can find 14. And we will find that this table is different from table A3 because in this table, we need to, if we want to find a critical range, we need the two sample sizes of the two groups. So we have already know that the two sample sizes is 14 and 19. So here we have already find 14 in the first row, and we need to find 19 from the first column. It's here 19. So in the cross position, the number is this one. But please notice that this is still a printing error in our textbook. This is not a number. This is not a number of 192.288. This is not a number. This is a range actually. This dot should be a comma. So this is a range from 192 to 288. This is the critical range. Okay, let's go back to our slide. We have already found that the critical range from the table A4, 183 to 293. And then it's similar with what happened in the first method. We compare the test the statistic with the critical range. If the t is inside the critical range, we will think that p is bigger than alpha. We cannot reject h0. But if t is outside the range, that means p is less than alpha. We need to reject h0. So here we can find that the t is 224.5. The number locates inside the critical range. So that means p is more than 0.05. So we cannot reject h0. However, if t is outside the range, that means if t is less than or equal to 183 or greater than or equal to 293, we reject the null hypothesis in favor of the alternative hypothesis. But in this question, we cannot reject h0. So the conclusion is there is no significant difference between the two groups. So that is the procedure of hypothesis test for two independent samples test. And the name of the method is Wilcoxon rank sum test for two independent samples. Okay, till now we still have the last type of method, which is the Kraskov-Wallis test, which is used for a comparison of more than two groups by using a method of non-parametric test. But in today's class, we don't have enough time, so we will finish chapter 7 in next class. Okay, so today's class is over. See you next time.